This is a video lecture for Math 140 for Tuesday, April 21st. And the topic is the ambiguous case of the law of signs. It sounds sort of like a detective novel, but it's actually a case of a certain kind of triangle where we have an ambiguity when we apply the law of signs. Let's remind ourselves what the law of signs says. If we have some triangle here, and we label these sides A, B, and C, and our angles are A, B, and C. The law of signs says that sine of angle A over A equals sine of angle B over B equals sine of angle C over C, or we could invert these and say A over sine of A plus equals B over sine of B equals C over sine of C. That's the law of signs, and we talked about that. And we mentioned two types of triangles, an AAS and an ASA. Two types of triangles where we can apply the law of signs unambiguously to solve these triangles. Now there's another type of triangle called an SSA, which is a triangle in which you know one side and adjacent side, and then an angle that's not between those two sides. And let me give you guys an example of this. So an example would be this triangle. And here we have an angle of 20 degrees. Let's just make this up here. This is 10 and this is 8. Okay. And then there's another triangle we could have, and this is where the ambiguity comes up. Where this is still 20 degrees, this is 10, and this is 8. Now these triangles are SSA triangles because we know a side, another side. We know two sides and one angle, a side, another side, and an angle that's not between the two sides. Okay, but we have an ambiguity here because both of these triangles are legitimate triangles given the given information. We could have this triangle or this triangle. And all the two sides and the angle are the same for each of these two triangles. So which one of these two triangles, when we solve these, we're going to get to an ambiguity. We have to learn how to deal with that ambiguity. We can still apply the law of signs, but we have to be careful here. And with these two triangles, we knew 2 out of the 3 angles. And since the angles of a triangle add to 180, that means we know the third angle. Whereas with an SSA, we only know one of the angles. So what that means is there's an ambiguity. If you see in this angle here, in this case, this angle here is acute. In this case, this angle is obtuse. And that's where the ambiguity comes from. So we need to learn how to deal with this. And let me erase this, and then we're going to consider another example, a different example. We're going to go through this carefully. And there's actually 4 different cases we can have when we have an SSA triangle. Okay, so suppose we have the following triangle. And here we go. Let's just draw this carefully. We have one side here. Then we have another side like this. And let's continue this out here. And then we have another side coming possibly down like this. This angle is 30 degrees. Okay, this is angle A. Let's label this appropriately. B and C is equal to 30 centimeters. Okay, this is angle B. And then this is side A. And this is angle C. But it's not really yet an angle. So what I want to consider here is we have this situation where we have this side length A, which we can imagine can vary in length. And there's a couple different possibilities if we have these numbers here. And I want to consider the situation where let's say this side A can kind of move like a lever or like a pivot, and it can move and come down. What if we dropped down side A? And what if we drop down side A and it just touched this side B there? In that case, we would have a right triangle. So one situation is we have this situation here Let's see if I can draw this correctly. And we have this angle is 30. Okay, this is 30 centimeters long. Angle B, angle A, angle C, which is a right angle, side length B, side length A. So let's say we can make A a variable length. And one scenario is A is just long enough. If it pivots down like this, it just touches side B. If it just touches it, the only way it can touch it is at a right angle. And this is now a 30, 60, 90 triangle. And I'll let you guys solve this, but if you solve this, it turns out side length A is equal to 15 centimeters. Okay, it's equal to 15 centimeters. If you had a situation where side A was 15 centimeters, you'd have a certain case. So let me go through these cases here. There's various cases we can have. Okay, case 1 is that A, so this is now applying back to this triangle. Case 1 is that A is less than 15 centimeters. Let's say A was less than 15 centimeters. Well, the minimum length of A to actually reach side B is 15 centimeters. So if it's less than 15 centimeters, we have no triangle at all. No triangle is formed. Okay, this triangle is not possible because A can't reach side B and the sides are not all touching. There's a second case, and the second case is A equals exactly 15 centimeters. And in this case, we have one solution. And that one solution is a right triangle. That one solution is a right triangle, and it's this right triangle. Now, we didn't actually figure out side length B, but we know this angle B is 60 degrees, and we could find side length B using Pythagorean theorem. So this is a simple situation to solve. Okay, a third case is if A is between 15 centimeters and 30 centimeters. This is the third case. And in this case, we actually have two solutions. We have two solutions, and one is an obtuse triangle and one's an acute triangle for the angle C. Let's draw these two triangles we could possibly have. So here's our side length 30. I've got a little bit bent there. And then it goes up here, and then we come down like that. I'm sorry, I apologize for this triangle, but I'm trying to draw it as best I can. This is A, B, C, B. This is C, C. And in this case, our angle C, so this is side length A, Side length A is greater than 15 centimeters, so it's able to reach side B, but it's less than 30 centimeters. And so it either could come down like this, and this is a case where C is obtuse. We have an obtuse angle, which means that angle C here is greater than 90 degrees. Or we could have another situation that looks like this. B, A, we know A is 30 degrees. This is 30, angle B here, angle C here. Okay, this is side length A. Or we could have a situation, again, where this is, A is between 15 and 30 centimeters in length. In this situation, angle C is acute, meaning it's less than 90 degrees. And these are both valid. These are both situations we could have. This is the ambiguity of an SSA triangle. We actually have two solutions. And then there's a fourth case, and I'm running out of room, but I'm going to erase this and mention the fourth case here. So the fourth case is that side A is greater than 30 centimeters. And in this case, we have just one solution. Okay, now think about this. If A is greater than 30 centimeters, there's no way you can have an obtuse angle C triangle, because if A is greater than 30 centimeters, there's no way you can fit it on the right side of this longer side, 30, right? If A is greater than 30, then there's no way that A can be here, because by definition it has to be less than 30. So if A is greater than 30, you can't have a triangle where angle C is obtuse. But you can have a triangle where angle C is acute, so let me draw that situation. Like this. You could have a triangle that looks like this, where this is still 30, this is angle A, this is 30 degrees, this is angle B, or side B, angle B, this is side A, this is angle C. Okay, now you have a situation where side A is greater than 30, okay, and C is now acute. You have an acute angle C. Now this is a fourth possibility, right? Because you could have side length A, which is clearly longer than 30. You could have this triangle, but you can't have a triangle where angle C is obtuse, where A is greater than 30 centimeters. So this is our fourth case. There's one solution here. So when we have an SSA triangle, what we need to do is a little analysis to figure out which case are we in. Are we in case 1, case 2, case 3, or case 4? And depending on the case we're in, we can then try to solve that triangle. If we happen to be in case 3, we're going to have to find there's two different solutions in case 3. By the way, one other important note. In case 3, these two, let's call this C star. Okay, C and C star are supplements of each other. And we could prove that, but let's just take that as true. It turns out these two cases, when we have case 3, the two solutions, in these two solutions, if you were to add this angle C and this angle C, those would add up to 180. So these are supplements of each other, and that's important to keep in mind. So this is basically a kind of a theoretical outline of the different possible cases we have. This concludes part 1 of this video, and in part 2, I'm going to consider an example problem where we go through these different cases.